Most of what you think you know about water is wrong. The most familiar substance in your life, the one you drink, swim in, clean with, and watch fall from the sky, is actually one of the strangest chemicals in the universe. If water obeyed the laws of physics the way it should, Earth would be a silent frozen rock drifting through space, and you would not be here to question it. But water refused to follow the rules. Today, we're diving into the story of a liquid so bizarre, so contradictory, so fundamentally impossible, that scientists still struggle to explain why it behaves the way it does. And once you understand what water really is, you will never look at a single drop the same way again. Water shouldn't exist the way it does. Every molecule around us behaves predictably. Metals expand when heated, gases compress under pressure, solids sink when placed in their liquid form. But water? Water is the rebel teenager of the periodic table. Instead of becoming denser as it cools, water expands. When it freezes, its molecules form a delicate crystalline lattice, pushing farther apart, becoming lighter and floating. This tiny, simple quirk is the reason every lake and ocean on Earth has not frozen solid from the bottom up. It's the reason the planet has seasons, weather, and life. Had water behaved correctly, Earth would have been trapped under kilometers of ice billions of years ago, and life would have ended before it began. Water is impossible, yet it saved the world. Zoom into a single molecule of water, and you'll find something deceptively simple. A V-shaped structure, two hydrogen atoms hugging an oxygen atom like a tiny cosmic boomerang. But this shape creates polarity, an imbalance of electrical charge that acts like a magnet. The oxygen side becomes slightly negative. The hydrogen side becomes slightly positive. This makes water cling to itself with surprising strength. Every molecule grabs the next one, forming endless chains, sheets, and networks. It's like billions of microscopic hands holding on tightly, refusing to let go. This invisible stickiness is what lets water defy gravity. In the tallest trees on Earth, water rises more than 100 meters, pulled upward by sunlight, evaporating droplets in leaves. The tension inside these microscopic tubes is so extreme that if your veins experience the same negative pressure, they would collapse instantly, and so would you. But water can handle it effortlessly. Water is the best solvent in the known universe, the universal dissolver. Salt, minerals, gases, nutrients, metals. Water tears them apart into ions and carries them anywhere it flows. The ocean is essentially a 3 billion cubic kilometer cauldron of dissolved earth. Every river on the planet is slowly eroding mountains, grinding rock into atoms, transporting them across continents, giving them back to the sea. Inside your body, water performs the same miracle every second, bringing sugar into your cells, pulling waste out, carrying oxygen, regulating temperature, and keeping every metabolic reaction from crashing into chaos. Life doesn't just use water. Life is built inside water. And yet water has even stranger tricks waiting inside its simplicity. Most substances in chemistry must pick a side, acid or base. Water refuses. It can donate a proton, acting as an acid, or it can steal a proton, acting as a base. It switches roles effortlessly, balancing the chemistry of the planet like a silent guardian. Your blood stays within an extremely narrow pH range because water is constantly buffering it. Your cells, DNA, proteins, every piece of you depends on this balancing act. Water is both chaos and order at the same time.
Cells maintaining chemical stability thanks to water molecules balancing charges.
We learn that water has only 3 states: solid, liquid, vapor. But the real number is closer to 70. Under intense pressures, the kind found in the deep mantle or in the cores of giant planets. Water crystallizes into bizarre, alien structures. Some phases look like spirals, others like cages or tunnels. Some behave almost like metals. Others remain solid, even at temperatures above the boiling point of normal water. Our familiar water is only one tiny corner in a vast landscape of possibilities. In other words, even when water is simple, it's not really simple. Why is water so strange? Because everything about it sits in a razor-thin zone of perfection. Its molecular angle, its polarity, its hydrogen bonds, all tuned with incredible precision. If any of these values were slightly different, the consequences would be catastrophic. No oceans, no rivers, no storms, no erosion, no cells, no biology, no life. Water is not just important. It's the single most improbable coincidence that allows Earth to exist as a living world. Every glass of water you drink contains molecules older than the sun, forged in ancient stars, recycled through billions of years of planetary history. You're drinking the cosmos. Over billions of years, water carved every valley and canyon, shaped coastlines, built fertile soils, and powered storms that cycle nutrients across continents. It regulates Earth's temperature, stores the sun's energy, drives climate, and forms clouds that blanket the sky. Every raindrop is part of the machine that makes Earth alive. Water is a miracle disguised as a mundane liquid. Water is the most familiar substance in your life, yet the most mysterious. A liquid that should not exist, but somehow became the foundation for everything. If this strange, impossible molecule could shape an entire planet, imagine what else in the universe might be hiding in plain sight. If you want more videos exploring the hidden mechanics of our world, consider subscribing. It really helps the channel reach more curious minds like you. And if you enjoyed this journey, stay tuned, because we're already working on the next one. A quiet miracle flows through Earth, and this is only the beginning of its story.